question 10, we have also the variable into places. It's a little bit more complicated because we have to multiply by using the distributive property of multiplication over addition in both sides. Well, we do that. We get 5x minus 20. We get minus 2x plus 6. Why plus 6? Because we have minus 2 times minus 3. Next step is to gather terms containing variables. So I am going to move negative 2x to the left. Here it is now. 5x plus 2x. Now here this was, once I multiply negative 20, negative 7, this is negative 27, which I can move to the other side as plus 27. So again, minus 27 is moved to the other side as plus 27. So now we have 6 and 27 because minus 2x was moved to the left as plus 2x. Now we have 5 plus 2 is 7x, 6 plus 27 is 33. Next step is to divide by 7 and we have our solution. And number 12 is done in a similar way. You can follow the steps and you will see how you get the answer x equals 2. Here we have question 16. In question 16, we have some kind of fractions. We don't have to be afraid of the fractions. We can work with them. But I decided to eliminate denominators because usually not many people enjoy working with fractions. So since my denominators are 4 and 2, I multiply by the least common denominator 4. When I multiply by 4 the left side, it will cancel the 4 here and I will have x by itself, and then 4 times minus 5 is negative 20. On the right side, 1/2 of 4 is of course 2. Next step is just to move negative 20 to the other side, so it will be 2 plus 20, 22, and that is the answer. Now 18 is done in a similar way, but I would like to focus on question 28. 28 originally is 2x plus 1/3 equals 6x plus 1 divided by 3. So following the same principle, I multiply by 3 left and right. When I multiply by 3 to x, I get 6x. When I multiply 1/3 by 3, I get 1. And here it just cancels out and I get 6x plus 1. And then I discover that what I have on the left is exactly the same as what I have on the right. What does it mean? Well, it means that no matter what number I take, if I take that number and I multiply it by 6 and then I add 1, I will get some kind of result. But that result is going to be exactly the same as I will get on the right side because I'm doing exactly the same. And that means that any number will work. That means any number is a solution. So as soon as you get the same expression on both sides, you can stop and you can say any number is a solution. Question 31 is a different kind. I'm going to leave it there because I'm going to show you, let's see, let's go back to 31. Okay. 31, we have the same principle. I could multiply by 4 if I wanted, but I'm going to eliminate 4, or I can just take this 4, which is in the denominator, and move it to the other side, multiplying. That will give me 4x plus 32. So I have, actually that's not what I did. So let me backtrack here. What I did here was I simplified. 4 divided by 4 is 1x. 8 divided by 4 is 2. So on the left side I have x plus 2, on the right side I have x plus 8. And then I say, well, let me put x terms containing x on the same side. So I can move x to the left, but it will cancel out with this x. So the x cancel, and I am left with 2 equals 8. What does it mean? it means that no matter what number I try, I will end up with something that is not true. That means no number will work. That means the equation has no solutions. Here we have 34.1. Point 1 usually means I change the question a little bit. You can follow the steps and you will get no solution for this equation. And here is a note, same as I was telling you, which is as soon as you see that the equality is impossible, you may stop, because there is no need to continue, because there is no solution. I say this because sometimes students tell me, how far do I have to go? Do I have to get 0 equals x or 1 equals 7 or whatever else? And my answer is, as soon as you see that the equality is impossible, you can stop. You don't have to continue. And now we are getting into equations with absolute values. Okay. Now, suppose we have this problem. Don't mind this 36 here, or this comment. Suppose we have absolute value of x equals 3. You know that that is true in either case, that x is 3 or if x is negative 3. Because if I have 3 at 3 or negative 3, it will be true. Right? Now therefore we can state the rule. The absolute value of expression 1 equals absolute value of expression 2 can be solved by stating the inner expressions 1 and 2 are equal, and by stating or solving the inner expression 1 is exactly the opposite of inner expression 2. So if we try to solve this problem 36.1, which is, I took problem 36 and I just changed it because it's easier to see the intention of the rule. We have absolute value of 2x minus 3 equals absolute value of x plus 7. We have two ways of going about this, or two routes. One route is that the two inner expressions, 2x minus 3 and x plus 7, coincide, which is here this. And the second route is that one inner expression is exactly the opposite of the other. One inner expression is the opposite of the other, which is this. So we solve both of them. In the first case we get x equals 10. In the second case, after going through the steps, I get x equals negative 4 over 3. And finally, I state that the solution set is the union of both, is 10 and is negative 4/3. So those two are solutions for my original equation with absolute values. You can test it and you will see that it works. Okay, let's look at question 38. Absolute value of x is 7. Well, that is very difficult, right? Of course, I'm kidding. So, that is clearly true if x is 7 or if x is negative 7. 42, same applies. 2x minus 3 equals 21. That will be true if 2x minus 3 equals 21, or if 2x minus 3 equals minus 21. So I solve both. The first case I just move negative 3 to the right, so 21 plus 3 is 24, and then I divide by 2 and get 12. In the second case, the same, negative 3 is moved to the right, so minus 21 plus 3 is minus 18. When we divide by 2, we get negative 9. So the solution to 42 will be 12 and negative 9. 46 is done the same way. The only here comment I would like to make is that when we have the absolute value of a quotient, we can say that that equals, in this case, absolute value of the numerator divided by the absolute value of the denominator. But since 4 is positive, we can just write it like this. And this makes solving this problem much easier. And you can follow the steps here. And let's see. On page 82, we have problems 48 and 52. In 48, they say the absolute value is negative 17. Now, listen carefully. Absolute value is negative 17. You immediately say no solution, because you know that the absolute value cannot be negative. So you stop. Now in 52, same page, even though there is an absolute value involved, and at the end they tell you that the result is negative 7, you still don't have the right to say that there is no solution, because there could be solution. For example, the fact that in baking a sweet you use salt doesn't make the sweet salty. So what you do is you start moving things around, right? So you take this whole term, which is negative, put it on the other side positive, take this negative 7, move it to the left positive. Now you have 12 equals 4 times the absolute value, divide by 12 4 times, right? So move it under, so it will be absolute value equals 3. So you see how the original expression is equivalent to saying that the absolute value is positive, right? And then you solve it using the approach, meaning 2 minus 5x could be negative 3 or could be 3. Solve both, and that will be your solution, the union of the two solutions.